Hello, Year 9 NAPLANs. I've chosen a few questions that I think are tricky questions, or questions that are really important for you to understand and know. In this question, a number is chosen at random from these cards, from 1 all the way up to 12. What is the probability that the number is both prime and less than 7? The reason I find this an interesting question is because it wants you to understand what prime is. And then also you have to pay attention to words such as less than. So you probably heard of that definition, that a prime number is one that can only be divided by 1 and itself. And so 2 would be a prime because it's divided by 1 and 2 only. 3 is also because it can be divided by 1 and itself. 4 cannot be a prime because it can be divided by 1 and itself, but it also can be divided by 2. So 5 is a prime, 6 is not, 7 is a prime, 8 is not, 9 is not, 10 is not, and 11 is a prime. And you may want to ask, why is 1 not a prime? Because 1 can be divided by 1 and itself, right? But historically it used to be a prime, but it is no longer a prime because there is a very special theorem, a very important theorem in mathematics that excludes 1 as being a prime. And this fundamental theorem of arithmetic is, it says that every positive whole number can be written as a unique product of primes. Now, I'm going to explain this, but you do not need to dwell on this. This is just extra curriculum for you. Let's say I've got a whole number 6. Now 6 can be a product of 2 primes. 2 times 3, because 2 is a prime and 3 is a prime. If I include 1, that means that 6 could be also a product of 1 times 2 times 3. Well, actually, it also could be a product of 1 times 2 times 3. Now, that no longer fits into this new theorem of arithmetic, because it says that every positive whole number can be written as a unique product of primes. And these are not unique anymore. So 1 has been discarded, 1 is no longer a prime. So you must remember, in your NAPLAN exam, always remember that if they ask you for primes, 1 is not included. Going back to my question again, I have highlighted all the primes in those cards. But the other part of this question says that it has to be less than 7. Well, definitely 11 is not part of it, so let's just delete 11. The other word that's really important is the one that says less than 7. It does not include 7, so let's also get rid of that. On the whole, we just have 3 numbers over here, and these 3 numbers, the probability of getting those 3 numbers out of the whole 12 cards is 3 out of 12. Therefore, 3 out of 12 is the same thing as saying 1 over 4, which means that our answer is E. I've chosen this particular problem for a particular reason. We are used to find, when we have a table, to start substituting the x values and the y values into our rules. And we would have to go through A and B and C and D. But time is very precious during these tests. So I want you to have a quick look, first of all, of what is actually going on over here with this particular table. I want you to note that the y values are decreasing. 6, 4, 3, 2, 1. Whereas the x values are actually increasing. 1, 1.5, 2, 3, 6. So the x values go in opposite direction to the y values. This means that instead of the y values increasing proportionally to the x values, so that when y gets larger, x gets larger. This is not the case. We have the situation where the y values are proportional to 1 over x. Say y is inversely proportional to x. In other words, when x gets larger, y gets smaller. For every x value which is getting larger, the y value will become smaller. Now, when you're looking at all your rules over here, notice that the very first one indicates that as x gets larger, the y value gets also larger. When we go to b, when x is 1, it should be 6, but it's not. It's 1 over 6, very small. The same thing occurs when we look at d. When we make x equal to 1, y is 7. When x is equal to, for instance, 6, y is 12, which is inversely proportional to what we have here. The only equation or rule that shows us the inverse proportion is C, where y is equal to 6 over x. This is what we call an inversely proportional rule. If you notice what's actually going on in the table, you can straight away decide to delete certain rules because you know that they will be wrong, and check the rule that you believe is going to be correct. So we can still check whether C is correct. So what we do is say when x is equal to 1, y is equal to 6 on 1, which is equal to 6. So that checks. When x, I'm going to go to 2 straight away because sometimes it's not necessary to do all of the numbers. Y is equal to 6 on 2, which is 3, and that also checks. And when x is equal to 3, y is equal to 6 on 3, which is 2, and we can see that we've got this rule correct. So x is equal to 6, then y will be equal to 6 over 6, which is equal to 1, and we've got it right. You want to still check the rule, whether you've got the right rule, but you don't have to go through every single rule. And so we can just highlight C. This pattern is formed by rotating the arrow in a clockwise direction. Now that's important. Through how many degrees is the arrow rotated each time? Because it's a pattern, it's obvious that each time you rotate the arrow, it'll be always through the same number of degrees, which means that it really doesn't matter whether you go from this to here, or from this arrow to here, or from this arrow to this arrow, or from this arrow to this arrow. You should always get the same amount of rotation. So the simplest thing for me, when I look at it, is to find an arrow which points to the north. I will now draw a compass with the center at the tail. So this will be my north, east, and then I have to still draw my south, which goes down, and west. So I decided that my first arrow is going to be this one. That means that my second arrow must be this one over here. And the question is, where do I now place my arrow? Do I place it head to tail, or do I place it tail to tail? In fact, I'm supposed to place it tail to tail because you're going to think about it as a clock arrow which is rotating. It's always rotating around like this. So now the arrow is here, a little bit like 7 or 8 o'clock. we need to now establish how many degrees has the arrow been rotated. So we know that there are 90 degrees between north and east, and we also know that there is another 90 degrees between east and south. Well, 90 and 90 will give us 180, but what is the angle between the arrow here and the south? It will be half of 90, and that'll be 45. So I'll write 45, and that means we add 45 here, and that'll be together 180 plus 45, which is equal to 225 degrees. So we can write 225 degrees over here. Now we don't have to go measuring every single arrow, because they are all in a pattern and have the same number of degrees rotated each time. Well, if you found this helpful, then please give me a tick and also subscribe, because that helps my algorithm goes much further, and a lot more people will be able to have access to this particular YouTube. It means a lot to me.